Here we are in lesson 12.5, but we actually moved this into chapter 13 because it fits so nicely with combinations. And here we are talking about the binomial theorem. And remember, a binomial is something like x plus 4, and it's raised to a power. And in the past, what we've had to do is, if this was to the fourth power, I would have to take x plus 4 times x plus 4 times x plus 4 times x plus 4, do lots of FOIL, and then combining like terms, and it just actually gets to be kind of messy. But we are going to look at using some patterns that have to do with combinations. So here there's just a definition for this. It says J and N are integers, and they're positive. N is bigger than J. Then we have this N over J. Now this is a combination. This is the symbol for combination. And if you remember, there's the formula for a combination. So if we take these values down here, if I have 3 and I'm choosing 1, how many ways can I do that? Well, 3 is our N and 1 is our J. So I'm going to have 3 factorial over 1 factorial and then 3 minus 1 factorial. So this would be 3 factorial over, now 1 factorial is just 1, so 3 minus 1 factorial is 2 factorial. So this would be 3 times 2 times 1, and then this is 2 times 1 divided by those, and I have a 3 left. All right, my pen's kind of getting a little light here. So how about if I have 4 choose 2? So this would be 4 factorial over 2 factorial and then 4 minus 2 factorial, or 4 factorial over 2 factorial 2 factorial. So this would be 4 times 3, and the 2 times 1 will cancel with the 2 times 1, just one of them. And then I'm left with a 2 times 1. So 4 times 3 is 12, divided by 2 is 6. If I have 8 choose 7, that would be 8 factorial over 7 factorial and 8 minus 7 factorial. So this is just 1. And 1 factorial is 1. So this is 8 factorial over 7 factorial. So if I multiply this out, 8, 7, 6, 5, 4, 3, 2, 1, it's going to cancel with the 7, 6, 5, 4, 3, 2, 1 on the bottom, and I'm just left with 8. All right, so just a real quick review on combinations. And remember, you can use those. You can do that on your iPad. In Desmos, you can use the probability and permutation and combination symbols, and it will do all the calculations for you. So now we're going to look at Pascal's triangle. And in Pascal's triangle, there are a lot of patterns. And I'm just going to kind of put this out here just to kind of explain this. Pascal's triangle starts with a 1, and then I have a 1 and a 1 here. So I have 1 1s, then in the second row I have 1 and 1, and our rows always start and end with a 1. So in my third row, I'm going to start with a 1. In the middle, I'm going to add the 2 numbers above it. So 1 plus 1 is 2, and then I have a 1 over here. Then I have a 1, Then I add these two numbers together. I get 3. I get 3 here, and then I have a 1. So in my next row, I'll start with the 1. 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4, and then I end with a 1. All right, I'm going to do another row or two. In my next row, I start with a 1, and then I add 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. Then I have 5, and then I have 1. Let's do one more row. So I have a 1. Here I have a 6. 15, 20, 15, 6, and 1. Okay, so they are symmetric. So you do have the numbers going up to the biggest number, and then you come down with the same numbers. So there's lots of patterns that we could use with the Pascal's triangle, but I just wanted you to realize how the numbers in the triangle are created. Now, if I think of this as, and I'm going to go back here now, and I'm just going to zoom in close. So let's say we always start with row 0. So something to the 0 power just gives us 1. So let's think of these as being our exponents. So especially in our binomials. So these are our exponents. And if I have something to the 0 power, I have 1. Something to the first power, I have 1 again. Something to the second power, okay, I have a 2 in here. This is to the third power. I'm looking at exponents here. Fourth power, fifth power. So if I'm looking at the rows, this is row 1. Or actually, we're going to start off with 0. So this would be row 1. This is row 2, 3, 4, 5, and I could keep going. Notice that we have a pattern here. 1, 2, 3, 4, 5. I could keep going 6, 7, 8. Okay. So when I'm using the Pascal's triangle, these numbers are not only the sum of the two, this number is not only the sum of the two numbers before it. I can also look at getting these numbers by looking at combinations. So if I have in row 0, 0, choose 0, there's only one way to do that. If you have 1, you choose nothing. There's only one way to do that. 1, choose 1. There's only one way to do that. And in the second row, 2, choose 0. 2, choose 1. 2, choose 2. And the number of ways we can do each of those are these numbers that are over here. All right, so each row, you're starting with a combination of the row number. So this is 5, and then I have 5, choose 0, 5, choose 1, 5, choose 2, 5, choose 3, and those are the numbers that are in the triangle. All right, so this just down here is a lot of some things that it's hard to understand. But if I have a binomial like x plus a or x plus 1, and then that's raised to a power, the coefficients in front of my exponents or in front of my variables with exponents, the coefficient is going to be the same number in the Pascal's triangle. Now, best way to do that is let's just look at one of these. All right, so I have the binomial x plus 2 to the 5th power. Now, here I'm actually going to have 6 terms because I'm going to have a 0 term, and then a 1 term, a second term, 3, 4, and then 5. So I'm going to look at those rows in the Pascal's triangle. So when I'm doing that, I have a coefficient, and this is just going to be the number from the triangle. And then I'm going to have an x to the 5th power, and then I'm going to multiply that by 2 to the 0 power. All right, and in this case, 2 to the 0 power would be 1. Then in my second term, I'm going to have a coefficient. My x value is going to go down 1, so I'm going to go 5 to 4, and then my a value, which is 2, is going to go up 1, so I went from 0 to 1. In my next term, I'm going to have an x and a 2. My x is going to be 5, 4, this is 3. And then the 2 is going to be 0, 1, 2. Now, if you look at each of my exponents here, you'll notice that they all add up to 5, which is my exponent up here. All right, so I'm going to have 6 terms, I told you. So this is 5, 4, 3. I have something with x squared, 2 to the 3rd. And then I have something with x to the 1st, 2 to the 4th. And then I have something with x to the 0, 2 to the 5th. Okay, I think I zoomed in, so let's look at that. All right, so now I'm going to go to my triangle and I'm gonna look for the 5th row because my n is 5. And in the 5th row, my numbers, oh, this is hard to see on this one. So 0, 1, 2, 3, 4, 5. So this is the row I'm looking at. These are the coefficients that I'm going to use to fill in the blanks. 1, 5, 10, 10, 5, 1. So I'm going to go back up here. I'm going to put a 1, a 5, a 10, 10, 5, 1. All right, so now I got some calculating to do because I can't just leave this right like this. It needs to be simplified. So if I look at this, I have 2 to the 0, which is 1. This is 1 times 1, which is 1. So my coefficient here is 1x to the 5th, or just x to the 5th. In this next one, I have a 2 times a 5. So this coefficient is 10, x to the 4th. Now I have 2 squared, which is 4 times 10 is 40, x to the 3rd. Then I have 2 to the 3rd is 8 times 10 is 80, and that's x squared. Then I have 2 to the 4th is 16 times 5 is also 80, and that's x to the 1st. And then I have 2 to the 5th is 32 times 1, that's 32, and x to the 0 is just 1. So this is 1 times 32, or just 32. So all of this is my expanded answer for x plus 2 to the 5th power. All right, let's do another one. This time we have a 4th power, so the number of terms is always going to be 4 plus 1 is 5. Okay, so whatever our n is, if I add 1 to that, it's going to be 5 terms. All right, so my first term is going to be 2y, and my second term is going to be 3. So I have a space, then I have 2y, and this is to the 4th power, and then I have minus 3, and I'm going to keep the negative with the 3 to the 0 power. Remember, they add up to the number that is the exponent, which is 4. Then in the next term, I have 2y, and this is to the third power, and negative 3 is to the first. So the 2y exponents are going to go down, and the negative 3 exponents are going to go up. And there's a coefficient there. I forgot to write that. So then I have 2y to the second power and negative 3 to the second power. Now I have 2y to the first power times negative 3 to the third power. And I have one more, which is 2y to the 0 and negative 3 to the fourth. Sorry, you can't see that. All right, so now we're going to go to our triangle, look at the fourth row. Okay, so that's going to be the row above 5 that we did before. So here, and this is for n equals 4 right here, I'm going to have 1, 4, 6, 4, 1 are the numbers that I'm going to fill in for my coefficients. So I'll put a 1, a 4, a 6, a 4, and a 1. So now I have more simplifying to do. Now here for my y's, I'm going to have a y to the fourth, but I have a 1 times a 2 to the fourth times a negative 3 to the 0 is just 1. So really I have 1 times 2 to the fourth is 16. So this is 16 y to the fourth. And then on this one, I have 4 times 2 to the third times negative 3. So this is 4 times 8 is 32, and 32 times negative 3, I did that calculation, is negative, so I'm going to have a minus 96. And this would be y to the third power. Okay, my y exponents are going to keep going down. My next one, I have a 6 times 2 squared times negative 3 squared, which is 9. So this is 54 times 4 is 216. This is positive, so this is going to be a plus 216 y squared. Next part, I have 4 times 2 to the first times negative 27. So negative times a positive, this is going to be a minus. 4 times 2 is 8, times 27 is also 216, and this is y to the first. And then on this last part, negative 3 to the fourth power is 81. 2 to the 0 power is 1 times 1 is just plus 81. And this is my solution. Okay, so just looking at your exponents here, you start with y to the fourth, third, second, first, 0. Okay, so you always have one more term than the number of exponents. All right, so example 4, it's asking us to find the coefficient of y to the 8 in the expansion of 2y plus 3 to the 10th power. All right, so I know that I'm going to have 11 terms here. And I only want to know one term. I just want to know the y to the 8th term. So in this case, this would be y to the 10th, 9th, so I want this term right here. This would be y to the 8th. All right, so if I'm thinking about my formula from the other page, and we're going to look at this here. Here I have N choose J, and I'm going to do this, use this formula here. So I need to figure out what N and J are. So N choose J. Now I know my number is the same as my exponent. So my number is 10. And I need to know what I'm choosing. And here I'm in the third spot. And I'm trying to determine how I'm going to explain this to you. But I've only used 2. So I'm going to do 10 choose 2, and I'm just going to see if this kind of works here in a second. That means J has to be, N minus J has to be 8. Okay, so I want the 8th term. So N minus J, now this is going to tell us what J is. J is what number? 10 minus 2 is 8. That's how I got the 2 here. Okay, so I have 10 choose 2. That's going to be my coefficient. My first term is 2y, so I have 2y, and this is going to be to the 8th power because I want y to be to the 8th. And then this plus 3 is going to be to the 10 minus 8, which is 2. Now remember, these two have to add up to 10. All right, so on my calculator, if I did 10 choose 2, actually, I'm just going to do that out to the side because I don't want to mess up my calculator for something later. So I have 10 factorial over 2 factorial, and 10 minus 2 factorial is 8 factorial. All right, so this is going to be 10 times 9, and then 8 factorial, 8, 7, 6, 5, 4, 3, 2, 1, will cancel with 8 factorial. And this is 2 times 1. So this is 90 divided by 2. This is 45. And then I have 2 to the 8th power. 2, 4, 8, I'm counting 16, 32, 64, 128, 256. Wait. So 2 to the 8th is 256, sorry. And then I have 3 squared is 9. So this is going to be my coefficient. 10 choose 2 is the number we put here. 2 to the 8th is 256. 3 squared is 9. If I multiply all those together, I'm going to get 103,680, and that's y to the 8th power. Woo! All right, next one is just like the last one we did. Here I want the 6th term of the expansion x plus 2 to the 9th. All right, so in the 6th term, so I have 9 terms, actually I have 10 terms, and I want the 6th term. So 1, 2, 3, 4, 5, 6. All right, so this is x to the 9th. This is 8th, 7th, 6th, 5th. So this is going to be x to the 4th power. All right, so I want x to the fourth power. If I write my combination, I'm going to have 10, and I'm sorry, I'm going to have 9 at 10 terms, and x to the fourth here, just like up here I had x to the 8th, I'm going to have 9 minus j equals 8. 9 minus j equals, actually in this case it's 4. That's the exponent in the 6th term. So here, j has to be 5. So I have 9, choose 5. And then this is going to give me x to the 4th times 2 to the 5th. And I know that these two both have to add up to be 9. 4 plus 5 is 9. So 9 choose 5, I calculated that already, is 126. 2 to the 5th is 32. Multiply these together and I get 4,032 x to the 4th power. And that's it. So this is just a lot of patterns and calculations with binomials, binomial expansion.